Hey folks, how's it going? My name's Steven. I'm a software engineer at Microsoft. I'm also a maintainer in the Istio project. I've been contributing to the project for almost 2 years now, and there have been various variations of this topic given at various KubeCon and events, and this is my first one, so I'm fairly excited. First, I want to introduce talk a little bit about Istio's architecture. Then we're going to get pretty technical into the systems point of view. We're going to talk about CNI and IP tables. We're going to look at how Istio Ambient does routing, load balancing. Then we're going to talk about the actual protocol that's used. And finally, we'll talk about waypoints and cover everything end to end so you understand how a packet moves through Istio. But before I do that, I just wanted to kind of gauge the room. How many people here have like a broad idea of what service mesh is? Okay, almost everybody. Who here uses service mesh in production? How many of you use Istio? Are you guys all in Sidecar, or are you some of you using Ambient? Wait, are you trying to migrate to Ambient? Yes, that's what I've heard. So hopefully this talk either gives you a good intro to Istio to Ambient, or an intro to service mesh in general, but I think the big takeaways I want you folks to have is to have a high-level understanding of how traffic moves through the mesh, the primitives Istio Ambient uses to make that happen, and maybe learn a little bit about containers. So a good place to start, as always, is with definitions. What is a service mesh? My definition is placing proxies in the data path to connect, control, observe, and secure workloads. So for example, sometimes you want to connect workloads not just within a cluster, but across clusters, or maybe even to external workloads, such as VMs. You want to control your traffic, either through smarter load balancing, such as topology aware, or you want to route in certain ways, such as path-based or canary rollouts. You want to observe your traffic, right? When things aren't working, you want to see why, what's happening through metrics and traces. And finally, you want to secure your traffic by verifying identities, by encrypting traffic so that observers can't see what's going on, and finally, enforcing authorization and authentication policies. And these are all things that a service mesh does. And it does so by placing proxies in the traffic path and having the proxies enforce do all these things. Like most service meshes, Istio is split into two parts, the data plane and the control plane. The data plane is just a set of proxies. In Istio Ambient's case, there is one ztunnel proxy per node. It's a daemon set. And there's an Istio-D, which is a control plane. The control plane's job is to read cluster resources, such as service or Istio-specific resources and cluster state, and it pushes that all as configuration to the proxies. When pods such as a client or a server send and receive traffic, Istio will set up traffic to be intercepted so that traffic goes through the ztunnel. Ztunnel can connect, control, observe, and secure the traffic, sends it to the peer ztunnel, and then the peer ztunnel will forward that traffic to the server transparently. And one cool thing about this kind of architecture is that ztunnel is very minimal. It doesn't do any L4, L7, it only does L4. And that means that it has very little code and a very small attack surface. At the same time, it's also very performant. And we'll see how having a very simple proxy as a daemon set will enable very incremental adoption. But first, I want to focus on a little bit about traffic redirection. This first connection between the client and the ztunnel. Because another thing about service mesh is that you don't need to configure your applications to get this redirection to work, so that redirection has to happen somewhere else. And to talk about that, we need to talk a bit about pod primitives. So this diagram by Ivan, I think, does a really great job showing the anatomy of a pod. as a collection of Linux namespaces. Linux namespaces are just different logical views of an operating system. So you get your own network stack, you get your own mount namespace, you get your own view of PIDs, PIDs, even though you're sharing the same kernel. And a pod is nothing more than a collection of these. And what this diagram does really well is it shows you that these network namespaces or UTS namespaces or IPC namespaces are completely orthogonal, which means that just because you're in a pod's network namespace doesn't necessarily mean you have to be in the UTS namespace or the IPC namespace, right? And the specifics of what a UTS or IPC namespace are don't super matter. The point is these are the things that create a container and that they are orthogonal. But for networking, the one that we care about is a network namespace. So the network namespace is usually set up by something called the CNI. When most people think CNI, I would imagine that you think of flannel, calico, or Cilium. Right, these are all kind of daemon sets that live in your cluster, and when a pod is created, Kubernetes will call out to your primary CNI, calico, Cilium, flannel, and their job is to set up your basic networking interface, Istio, loop back, assign them IP addresses, and create the routes so that traffic can flow from pod to pod. But a less known aspect about CNI is that this is actually a generic interface used to create the pod's networking environment. That means that you can have multiple CNIs chained together, and they run sequentially to set up the environment. So after the primary CNI runs, you can have other chain CNIs run that do other things to the network environment, such as add additional interfaces or set up rate limits. And in Istio's case, there is an Istio CNI that when the pod is being created, the Istio CNI will set up all kinds of traffic redirection. And it'll do that using two primitives, setNS and IP tables. setNS is a system call that allows the current thread to enter a different network namespace. Remember that diagram from before? It allows you to move across these pods and look at different network stacks or in different network namespaces. And finally, you have IP tables, which allows you to configure traffic redirection rules. So I know that's a lot of things, aspects, moving parts to put together. And just to get a good diagram, when a pod starts, a network namespace is created by Kubernetes. That network namespace is then going to be configured by the primary CNI, as we saw earlier, to create your basic devices, interfaces, and routes. And this is all very standard and necessary for any Kubernetes cluster. But then what's going to happen is that that Kubernetes is going to invoke the Istio CNI. The Istio CNI is going to use setNS to enter the application pod's network namespace, and then it's going to use IP tables to redirect traffic, plain outbound traffic to localhost 15,001, plain inbound traffic to localhost 15,006, DNS to localhost 15,053, and some other stuff to kind of set everything up. And the reason these ports are special is because Istio CNI will send a UDS message to the ztunnel on that node, and then that ztunnel will also call setNS, enter that pod's network namespace, and bind to the corresponding ports. And the point I really want to take home here, I really want to emphasize here, is that all the traffic redirection is happening inside the application pod. And ztunnel is listening to the redirect traffic inside the application pod. A lot of people think that because ztunnel is a node proxy, right, there's one per node, that the traffic redirection will leave the traffic leaves the pod and then gets redirected to ztunnel. And this is how it worked maybe like 3 years ago, but we've refactored so that everything happens inside the pod network namespace. And this kind of gives us two different views of what ztunnel really is. if you just do k-get pods in a node, you might see some application pods and ztunnel and assume that these are completely separate, that they all live in their own isolated network namespace. But in reality, if you go into these pods and you look at the listening sockets and you look at the traffic redirection, ztunnel is very much living inside of them and listening and traffic and forwarding traffic. And in this sense, ztunnels act a lot like sidecars. They are very much part of these application pods. One really good analogy, I think, is comparing these to these clonal colonies. These are really big forests, and if you look at them from the air or from the ground, it looks like you have a bunch of different trees. But this is actually just one massive living organism that sprouts up in different places. Much like how ztunnel, there's only one ztunnel per node, but if you look at all the pods in that node and look at the networking, you will see ztunnel in each of them. So depending on which view you take, there's either one ztunnel or multiple ztunnels popping up in different places. So at this point, we've covered how a pod's networking gets set up and how your initial traffic gets redirected to ztunnel. Once ztunnel receives a packet, it'll inspect the original destination, and then if it's a service, it'll pick a pod. If it's a pod, well, then it already has a pod. And then it'll create a socket again in the application's network namespace and send traffic. So all outbound traffic happens inside the application pod's network namespace. Rarely does ztunnel actually send any traffic from its own network namespace other than to communicate with Istio and receive configuration. Once it's picked a destination and created the networking socket in the application's network namespace, it will start forwarding traffic. But we want to do this in an intelligent way. So the first thing that we have to do is establish a TCP connection to the peer ztunnel, and this just allows traffic to flow. But we also want our traffic to be encrypted. So we have a layer of TLS. In fact, this is MTLS. So each ztunnel will verify each other's pod identity. And this allows us to make sure that we're talking to who we think we're talking at in a way that is cryptographically verifiable. But instead of just forwarding traffic through the TLS stream, we actually set up an HTTP2 connection. And inside the HTTP2 connection, or the HTTP2 connection allows us to multiplex multiple HTTP2 streams. And that's where the actual application traffic flows. And this seems like a lot of work, especially for the HTTP2 stuff, for a single connection. But what's really cool is that because you can multiplex multiple streams over an HTTP2 connection, if these two containers want to talk again, you can have a second HTTP2 stream. And this allows us to skip the whole three-way TCP handshake, four-way TLS handshake for every new connection. Right? The point being, you can establish these secure connections a lot faster. So one thing that I mentioned earlier is that ztunnel is a very minimal proxy. It only does L4 stuff. It does encryption. It can do some basic authorization, authentication, and some very basic load balancing. But that's not enough to be a fully service mesh. Right? Sometimes you need L7 capabilities. And that's where waypoints come in. Waypoints are effectively a gateway into a namespace, a service, or you can also attach them to individual pods. And if you configure a pod, a service, or namespace to have a waypoint, then ztunnel will route all the traffic through the waypoint. The waypoint will apply the L7 policies that you configured, whether that's HTTP, gRPC, and we're working on getting the waypoint to not just be Envoy, but also agent gateway, so we can support protocols such as MCP. And then the waypoint will forward traffic to the destination ztunnel. And this architecture is great because it allows you to opt in for L7 processing, but only when necessary. So at this point, the traffic has gone from the application to its ztunnel, and it's being forwarded. Maybe it's gone through a ztunnel, maybe it hasn't. And then the HPhone is going to arrive at the server ztunnel, listening on port 15,008. Once the traffic arrives there, the ztunnel will again do MTLS, enforce any authorization policies, and then it'll forward traffic to the server. But it's not so simple because it'll call the set socket option called SO free bind. And this allows ztunnel to bind to the address of the client's pod IP. So if you inspect the IP packets, the source IP isn't that of the server, isn't that of any ztunnel, it's actually that of the source pod. So then when the server sees the traffic, it thinks it's getting traffic directly from the client pod. And this is really powerful because the server gets the complete illusion that traffic is just being forwarded, sent to it from the pod, and it doesn't know about ztunnel at all. So to go from the end-to-end flow, first you have a client, and it sends traffic. At this point, the CNI has set up IP tables and has told ztunnel to listen on the ports inside the pod. The IP tables will redirect the outbound traffic to port 15,001 in the ztunnel. Ztunnel inspects the original destination and creates a socket inside the client application network namespace, inside the application pod, and forwards traffic using HBone to the peer ztunnel. Ztunnel then inspects, does any authorization or authentication it needs, and if everything passes, it will forward traffic to the server. And if you need waypoints, then there's a waypoint here. And all of this happens completely transparently. The client doesn't know about ztunnel. The server doesn't need to know about ztunnel. It's very hard for them to find out that they're in the mesh. But the result is that you get you get to control, connect, observe, and secure your traffic without any configuration of your individual workloads. That's most of my presentation. There's still a lot more that I didn't cover, but they also work in very similar ways. You have non-mesh traffic, right? Sometimes not all of your destinations or source pods are in the mesh for various reasons. They don't have a ztunnel. In that case, ztunnel will just send plain TCP traffic. You have gateways, ingress and egress gateways. These are points where traffic comes in and out of your cluster. That works very similarly. You're still using the HPhone protocol I talked about to communicate between the two. Multi-cluster, Istio Ambient recently last year, and we're working towards getting this to GA, allows you to connect multiple clusters, even if they have conflicting IP ranges. And what we do is pretty cool. We actually end up having to wrap HPhone inside of HPhone to get that to work. And finally, there's also DNS, which is fairly simple. You just redirect all DNS to ztunnel, that's listening on 15.053, and then if ztunnel knows about it, it'll reply. If not, it'll forward it upstream. Yeah, thank you for coming to my presentation. I'll take any questions. Yeah. Do you mind speaking up a bit? Actually, there's a mic coming.
In earlier demo, we saw that they had proxy handling all the secrets, not as a config map, but that's what was shown in the demo that, hey, all my secrets are being handled through proxy. Now that there's no proxy, would Waypoint be doing? Waypoint is, again, authorization layer. Where would I, and this is just because we saw in the demo earlier with Claude, that they had all their secrets buried inside the proxy. So when they're connecting to Claude, their key, et cetera, was handled by proxy. Now, with no proxy, where would that go?
So, for example, you have some workload. You don't want to give it, sorry, let me repeat the question. So you have these secrets, usually API keys, and you want to connect to some external service, and you want to inject that key into the traffic so that your individual application workloads don't have to worry about the lifecycle management of the key. So that's a great use for egress gateways. You can say, hey, for this kind of traffic to this service, you just have the application send HTTP traffic. The ztunnel will encrypt it, send it to the egress gateway, and then on the egress gateway, you can configure it to add the key and the authorization bearer token.
We currently are still not using Ambient. We do leverage proxy a lot, but we do not have any egress gateways set up. We only have ingress gateway. So that means we require, if we are moving to Ambient, we would need egress gateway as well?
Yes. You can also do this in Sidecar too, but any sort of L7 manipulation, you're going to need some sort of gateway to mutate the traffic.
Anybody else?
How does ztunnel manage like resource fairness on the node level?
Yeah, that's a tough question. I don't think I know the exact details off the top of my head, but I know that I think the story we usually give is you're already kind of sharing underlying resources on the node. It's not too different from ztunnel. Yeah, I don't have a great answer for you, sorry.
I have one more question.
Yeah.
You were sharing around IP tables. I had one more question, which was in your slides you had IP tables, right? What if I'm moved over to eBPF?
So Istio, we've tried eBPF before. I think we ran into some licensing issues. So right now, Istio only really supports IP tables. But if your CNI uses eBPF, say you're using Cilium, that's totally fine because that eBPF stuff usually, with a few exceptions, happens on the node level, so outside of the pods network namespace, and all the redirections happening inside the pods network namespace. So you can use, with a little bit of configuration, you can use Istio and Cilium. They integrate very well.
So we are running it in our, I would say, lower environment. We are actually testing with GKE data plane v2, leveraging Cilium and eBPF with Istio, but Istio with sidecars. Mm-hmm. Should we foresee anything if we are planning to move to Ambient?
No. Not that I know of. I know that there are a few configurations that you need to worry about with Cilium. Like, for example, you have to tell Cilium that there are other chain CNI plugins. Otherwise, it kind of overwrites them, and you get into this loop where the Istio writes the configuration, and then Cilium overwrites it, and then Istio overwrites it. But it's like 1 or 2 home values max.
Yeah, I haven't done any of those, but the traffic is running smoothly because in my non-prod environment, we did just the data plane v2 for GKE, enable Cilium and eBPF, and we're just running Istio. I think it's 26.8. Sorry, we're a little behind in our rollouts, but I haven't seen any issues, and I didn't have to do anything. So that's interesting.
Yeah, and that's kind of an issue we actually ran into when we were doing our original implementation of ztunnel or Ambient, is that we had all the traffic redirection happen on the node with IP tables. But as you say, if you're using eBPF, then it's not going to work. Or if you have other CNIs that also work with IP tables, those IP tables would clash with each other. And so that was one of the big driving factors of moving to this, we call it in-pod mode, where the traffic redirection happens inside the pod. So ztunnel is almost always CNI agnostic.
Okay.
I'll ask you to catch up later. We've got time for a couple more questions, so you guys, and the rest of you can catch up.
Hey, how's it going? I'm in the process of migrating my company from Envoy sidecars to Istio Ambient, currently only in development. One question I've been exploring is non-mesh workloads. So in particular, our goal is to use Istio Ambient for our main microservice, service-to-service communication. As I look at development logs, there's a lot of noise from things like just calls to Datadog and other things that are not intended to be on the mesh. I guess my question is, I'm doing this currently in permissive mode, and I'm using things like annotations that just exclude traffic to Datadog. What is kind of the best practice? Is the goal? It seems like the goal should be to get to full restricted mode in production, and I guess really just looking for like, what is the best practice here?
Let me try to understand the question. You're saying that you have external traffic, which means that you have to run in some sort of permissive mode, right? Because Datadog isn't gonna spin up a ztunnel just for you.
No, of course, but like, couldn't you exclude the traffic? There's, I forgot what exactly it is, but there's like annotations in the product.
I see, so you're saying you want to exclude certain traffic from being captured by ztunnel altogether?
Correct.
Yeah, so ztunnel, I think we purposely tried to not support that. There are other ways you can connect to external services. You can create service entries and tell ztunnel that, hey, these external services exist, and it's okay for traffic to go to these that are not in the mesh, and then you can connect to those. But generally, we try to avoid any sort of, this kind of traffic gets redirected or captured. This kind of traffic doesn't.
Cool. And is the general best practice to get into restricted mode, or does it just depend?
Yes, yes.
Cool. Thank you.
From the platform side, what's kind of the best practice for deploying waypoints? It's my understanding that they're supposed to kind of live in the same namespace as the destination pod, but from a platform side, that kind of makes it difficult to manage and deploy it if the application teams also have permissions to see into that and run workloads in the namespace.
Yeah, you can have cross namespace waypoints. Generally, the reason why we build waypoints to be for a per namespace is that waypoints are, we try to think about namespaces as trust boundaries. So you generally have very high trust for things inside your namespace, and things that are not in your namespace, you don't really, you trust a little less. So generally our suggestion is to have one waypoint per namespace or per service, depending on your trust and how you want to set it up. Yeah. I think, I'm curious, when you say you don't want your application teams to worry too much about this Istio infrastructure, right? Is it a big deal that you guys you're configuring things in their namespace? Because at the same time, you're also configuring, you're having the mesh enrollment labels on the namespace too, right? So it's not like you can be completely hands-off.
Yeah, definitely not trying to be completely hands-off. It's more around, one, now they can potentially see and or modify the waypoint, and two, we ran into a random thing the other day where the waypoint deployment, since it's running pods in their namespace, was counting against their resource quota.
I see.
So then all of a sudden we're having to recalculate our resource quotas to account for waypoint overhead, in addition to their actual workloads and random other things like that.
I see, yeah, that's fair, and I haven't really thought about that. But I think generally in Istio we try to think about trust boundaries before cost, and the namespace is generally a good trust boundary.